All right, guys, so here we go. We're going to learn how to solve a differential equation that has an exponential solution. So when do we normally run into this? There's kind of a popular differential equation that might pop up in one of your questions later, and that's whenever you have dy dt, our differential equation, equal to some constant times our output function y. So this is that constant proportionality. We had some of these earlier. We had to set up. Now we have to solve them. Usually they have a simple solution, though. They kind of run under that same format, and your solution is an exponential function. So let's go ahead and look at this example. So we have dy dt equals y. So to solve this, let's go ahead and get our y to the other side. So I'll divide by y. So let's cancel out. And on the other side, we'll multiply by 1 over y. So we'll have 1 over y dy equals 1 dt. Let's go ahead and integrate both sides. And the antiderivative 1 over y is natural log of y, which equals t plus c. Now you can solve for c at any moment of time, but my recommendation is to take care of that right now. The earlier the better usually. And so let's go ahead. We have our initial condition. When t is 4, y is 1. So when t is 4, y is 1. So let's just go ahead and plug that in. So we're going to have natural log of 1 equals 4 plus c. Now natural log of 1, sometimes you get like natural log of 10, natural log of 11, natural log of 3. You have to leave them like that. But there are two simple natural log evaluations. Natural log of 1, e to what power is 1? Well, e to the 0 power is 1. Similarly, natural log of e would just be 1, which is not what we see here, but these are the two easy natural logs to evaluate. So, natural log of 1 is 0. Solve for c, and we get that c is negative 4. I'm going to go ahead and substitute that in for c. Natural log of y equals t minus 4. And let's go ahead and solve for y now. So we're going to raise each one with the base of e. And the reason why we do that is that's what's going to cancel out that natural log and give us y by itself. So y equals e to the t minus 4. So technically, if this was a free response question, you're done. You wouldn't have to do anything from here. But that's not always the case with multiple choice. They might change the form of this. So let me show you. When you multiply numbers of the same base, you add the exponent. So we can split this up like this. See, it's just going backwards from that idea. E to the t times e to the negative 4 is the same thing as e to the t minus 4. And so from there, though, this is a negative exponent, so that could go to the bottom. So that'd be e to the t over e to the 4. And right there, what you'll see is the solution. Can be written three different ways. This first one's good for multiple or for free response, but the reason why this one, why I went through all these optional steps, is for the multiple choice, just in case for the multiple choice. So overall, this problem, it's just too easy.